Hello everyone, my name is Priyanka and I welcome you all to my session. So let's read a question which is telling us to use Ampere's circuital law and then obtain an expression for the magnetic field along the axis of a current solenoid of length L and having n number of turns. So a solenoid consists of an insulating long wire closely wound in the form of a helix. Its length is very large as compared to its diameter. Now, at the point outside the solenoid, the magnetic fields due to its neighboring loops oppose each other, and at a point inside the solenoid, the magnetic fields are in the same direction. As a result of it, the effective field outside the solenoid becomes weak, whereas the magnetic field in the interior of solenoid becomes strong and uniform, acting along the axis of solenoid. So let us make our apply Ampere's circuital law into this. So first we have to make it. So here just the part of solenoid, so here the magnetic field lines are coming out, so which is represented by a dot, and at the other end they are going inside, so it is represented by a cross. So inside, as we said that the magnetic field lines are the strongest, so we are going to represent by the straight lines B. And as I have just said that the magnetic field lines outside the solenoid is 0. So that's your B in this direction. So now let us consider a rectangular Amperian loop PQRS, something like this. Let's name it as P, Q, R and S near the middle of the solenoid, where PQ is of length L. So the total number of turns in the length L, so total number of turns in length L is equal to N into L. Now the line integral of magnetic field induction B over the closed path PQRS is given by the closed loop of B dot dl. That is, now we are going to apply the Ampere's circuital law PQRS. So what we can do now is that we can divide it into 4 parts, that is the line integral from P to Q, from Q to R, B dot dl, then R to S, and then again S to P. All of them are the dot products of the vectors, so let's make the arrows as well. Now go for P to Q. Alright, so we are just going to solve them all together separately. PQ B dot dl is we are going to open up the dot product, so P dl cos of 0 degree, because the angle between length and B is 0 degree, so it comes out to be B, which was a constant, and then the integral of dl, that is from P to Q, so it comes out to be BL. Now let us talk about the part QR and SP. So here we can say that the length component and the magnetic field component are making an angle of 90 degree. So we can say that Q to R B dot dl is B dl cos of 90 degree, which is 0. And the similar case is with S to P B dot dl. So both of them are going to be 0. So we can say that this component Q to R is 0 and this component S to P is again 0. So now this component we have solved, we are left with this component now, the third one. So when we talk about the third one, we can say that, the magnetic field outside the solenoid is 0. So B dl from R to S, so here B is 0, which implies that this component again goes to 0. So we are just left with this component, that comes out to be BL. So now Ampere's circuital law, B dot dl is equal to mu naught into the total current through the loop PQRS. So we can write BL as equal to mu naught into the total current flowing across the total length. So the L gets cancelled, so we just get B as equal to mu naught N into I. So that's the value of magnetic field of a solenoid. So I hope I was able to make this derivation clear to you. Thank you so much for your time. Have a great day. Bye bye.